Hello, algebra students. We're ready for section 5 of chapter 10, where we are going to be talking about the Pythagorean Theorem. I'm skipping over those review problems. We'll do those later. Right now, I want to talk about this theorem that's called Pythagorean Theorem. It is geometry. You're going to see this again next year in geometry, and you should have seen a little bit of it last year in pre-algebra. The wonderful thing about the Pythagorean Theorem that makes it so special is it's in an exclusive club. It's in the right triangles only club. Right triangles only. Pythagorean Theorem will not work for any other triangle, only for right triangles. So as we read the theorem in words, it says, if a triangle is a what? A right triangle, then this all will apply, only if it's right. If it's not a right triangle, how do we know if a triangle is a right triangle? You have to look for the box. If there's a little box in the corner, that means it's a right angle, so we could say this is a right triangle. When you have a right triangle, the square of the length of the hypotenuse, what is that? Is equal to the sum of the squares of the lengths of the legs. The hypotenuse is always the side opposite the right angle. The right angle is like a little arrow pointing to the side called the hypotenuse. The other two sides are called legs. We usually refer to them as leg number 1 and leg number 2, kind of like thing 1 and thing 2. However, we're not saying that they're equal. Just because they're both called legs does not mean they're equal. This is what the Pythagorean theorem looks like as an algebraic equation. The hypotenuse squared, the hypotenuse is always the longest side called c, equals a squared plus b squared. So what are the terms for, or the parts of, a right triangle? First, the hypotenuse, which we said is always the side across from the right angle. So remember to locate that right angle and think of that as an arrow pointing to the hypotenuse, the longest side, which is always called C. And the other two sides are always called legs. So it doesn't matter which one is leg 1, which one's leg 2. They're always called A and B. The two legs are A and B. All right, for right triangles only. I have a little treat for you. I hope it's going to work. Okay, that was just a little bit of fun we were having last year learning the Pythagorean Theorem. I don't know if you caught the very first line of that song. It says, Pythagorean Theorem is for right triangles. So again, it only applies to right triangles. Now, this next section of your notes, is called the converse of the Pythagorean Theorem. Now, the converse says that if the square of the length of the longest side, now we've been saying the longest side is the hypotenuse, but hang on, we don't know whether we can call it a hypotenuse yet or not. If the square of the length of the longest side, the square of its length, is equal to, if it is equal to the sum of the squares of the lengths of the other two sides, we're going to call those legs, aka legs, then guess what? Then we can say that the triangle, and that's the abbreviation for the word triangle in geometry, by the way, then we can say that the triangle is a right triangle. Okay, the converse Pythagorean theorem. Let me show you what that looks like. skip on down. I know there's another blank there, but for just a second, let's say so right here, for just a second, let's say we have 3, 4, and 5. If those are lengths of sides of a triangle, which one's going to be the hypotenuse? Well, the only one that could be the hypotenuse is 5, because it's the longest side. If the square of the length of the longest side, so here we go to test it. If 5 squared is equal to the sum of the squares of the other two legs, so that'd be 3 and 4, if it's equal, so we're checking to see if 5 squared equals 3 squared plus 4 squared, then we can say that this was a right triangle. So here's what's going to happen. We're going to get 25. Does that equal 9 plus 16? It sure does. So 3, 4, and 5 are three sides, are three measurements of a triangle that we know the triangle had to be a right triangle. So if the question was, is it a right triangle, you'd say yes, right triangle. Yes, it's a right triangle. Now the measurements 3, 4, and 5 are what we call Pythagorean triples. Okay, they're a group of 3 natural numbers that make a right triangle. I know in geometry books they give you a list of some very famous Pythagorean triples, and 3, 4, 5 is the first one almost always listed. So the more you practice with right triangles, the more you can recognize those Pythagorean triples. Okay, so as we turn over to the back, we're ready to work some problems. So first we're just going to practice using the Pythagorean theorem. Remember, a squared plus b squared equals c squared, where c is always the hypotenuse. So c is our longest side every time. So here's our hypotenuse, and here's our hypotenuse. All right, so let's go back. B squared, I don't know what that side is, plus 9 squared, there's the other leg, should equal 16 squared. So b squared plus 81 equals 16 squared is 256. Subtract 81 from both sides. And b squared equals 175. So to find the length of b, we know to take square root of both sides. And so it's either plus or minus, but because we're dealing with lengths, we don't have to worry about the negative. So it's the square root of 175, which simplifies 25 times 7, so it's going to be 5 radical 7 is the length of b. All right, for number 2, we would say 18 squared plus the square root of 24 squared. We know it's a right triangle, equals the hypotenuse squared. So 18 squared is 324, and the square root of 24 squared is 24. When you add those up, you get 348. And to unsquare c squared, we need to take the square root of both sides. Again, if it was an algebra problem, we'd have to say plus or minus. But since it's geometry, we break down 348 as 4 times 87. And so it's going to be 2 radical 87 as our length of c. All right, I'm going to let you practice number 3 on your own. Let's move on down here where it says find the length of the hypotenuse of a right triangle. So they gave us A and B. We have to find C. So we'll plug in 25 plus 60 squared equals C squared. And I am again going to ask you to go ahead and finish that on your own. Now here's a fun little cartoon for your enjoyment. You may be right, Pythagoras, but everybody's going to laugh if you call it a hypotenuse. I don't know why he called it that funny name. All right, so one thing I didn't tell you on the front. If you check the sides of a triangle, if a triangle has side lengths of A, B, and C squared equals A squared plus B squared, we said on the front, then we know the triangle's a right triangle. I did not tell you that if C squared does not equal A squared plus B squared, then the triangle is not a right triangle. In geometry class, you get to find out what kind of triangle it is, whether it's obtuse or acute. And I betcha you can figure out which one's going to be obtuse and which one's going to be acute. We might talk about that in class tomorrow. But just know that if it's not equal, then it's not a right triangle. So we have to determine if these lengths make a right triangle. And the longest side is always the hypotenuse, the potential hypotenuse. It's left alone. And the other two get squared and added together because it's the sum of their squares. So when we check 15 squared is 225. Does that equal 49 plus 144? And 225 does not equal 193. So therefore you say it's not a right triangle. That's all you need to say. All right, I'm going to let you do number 2 on your own. Tell me if you think it was a right triangle or not. Then we have a real world example on the back. Did you all know that televisions, when you go to the store to buy a television and they say it's a 32-inch or a 54 or 60-inch television, that they are measuring the screen diagonally? So on this television here, we have a right triangle. The diagonal of the television is 32 inches because they called it a 32-inch television. All right. The width of the television is 21 inches, and they want us to find the height, h. So I'm going to call it h for height. But we know it's a television, so surely the engineers of the television made it a right triangle. There's some things that you can't assume it's a right triangle, but for something like this, we know that it's a right triangle. So to find h, we say h squared, the height squared, plus 21 squared, because those are our legs, equals 32 inches squared. And so we end up with h squared equals plus h squared plus 441 equals 1,024. Subtract 441 from both sides, and h squared is going to equal, I don't have room here, 583. So we're going to have to take the square root of both sides, and last time I checked, 583 doesn't break down, so it's approximately 24.1 inches. But really, the square root of 583 is the most accurate, and we're talking about inches there. So that's going to be your height of your television screen. All right, I'm going to let you try this next one on your own. It always helps me to draw a picture. So Amarita is hiking. I think that's how you say your name. She's going directly east from her camp. And she walks for 6 miles before she turns right. So this is 6 miles, and then she turns a hard right. There's our right angle, and she walks 7 more miles south. All right, after her hiking, how far does she need to walk for the shortest route to go straight back to camp? So we're looking for the length of the hypotenuse, because that would be the shortest route back to camp. So she went east, and then she went right, going south, which lets us know from east to south makes a right angle. So for that, Pythagorean theorem can be applied to find out how her shortest distance, what's the length of her shortest distance. I'll let you finish that on your own. I'll be checking that one tomorrow. Have a super day.